So before starting the session, I'll be expecting you people to be familiar with at least one language, one programming language, that is around C++, C, Java, Python or anything like that. Because that's the basic prerequisite of starting with the design analysis of algorithms, that is DAA. What is an algorithm? Okay, let's just first understand what is the basic need of an algorithm. The first thing is, an algorithm, as is stated in the book of Corman Algorithms 3rd edition. I'll be taking references to two books. First is this Corman Algorithms, and then second is Fundamentals of Computer Algorithms by Ellis Horowitz. Okay, so according to these books, it's written that an algorithm is a well-defined computational procedure that takes some values or set of values as an input and produces some values or set of values as output. Now, this is what is written in Corman algorithms. Whereas in this book, that Fundamentals of Computer Algorithms, it is written that an algorithm should have 0 or more than 0 amount of input, but definitely should have 1 or more than 1 outputs. By output, here they don't mean that there needs to be an output screen in the console, okay, like cout or something, or printf type of something. That's not necessary. You can, let's take an algorithm, an sorting algorithm, okay. You're just sorting an array, but not at all printing it, okay. Doesn't make any changes. Still an algorithm. Why? Because a manipulation has been done to a data set. Which data set? That array data set, okay. A manipulation has been done. Definitely, it's not been printed by us right now, but still the manipulation has been done. So the output is there, we just can't see it. So that is what the basic necessity of an algorithm is. It should take or it may not take input, but definitely should give 1 or more than 1 outputs. That is the basic need of an algorithm. Moving forward, this is the basic thing that you'll know. These are my notes from the class. So, sequence of steps to solve a problem, that's the basic thing. Yes, an algorithm, what is it? It's this sequence of steps that is made to solve a problem. Which problem? Some real world problem, some computational problems. Those are being solved with an algorithm, okay? How to write an algorithm? See, before you start, let's take an example of sorting. Before you start sorting an array, the basic thing that we start with is thinking that yes, I'll search the whole array, see whichever is the minimum value, and then keep it in the first place. Okay, this is what layman process. This is what is called layman process. Okay, I can write it down inside in the paper. Yes, step 1 we see which is the smallest number, and we'll keep it in the first place, and the number which was in the first place will be swiped to the place where the smallest number came from. Okay, now this is a layman process. We have multiple more processes like a flow chart or something like that, but coming to an advanced level, there comes pseudocode. Now, pseudocode is a code which can be read by a programmer of any language. He or she can be a Python programmer, a C++ programmer, a Java programmer, a Golang programmer, doesn't matter. A pseudocode is a basic code written in simple language without using any syntax. That's the basic thing a pseudocode is. Okay, so these are the processes that you first think about the problem, see what the possible approach is by a layman process. Then you eventually form a pseudocode. Now this pseudocode will further be changed into a program. We are not looking into that. This was just algorithm. This was just about how to approach to write an algorithm. Okay, then there is design approach. What is design approach? There are multiple algorithms. Okay, one algorithm might take there are multiple sorting algorithms. One of them is like bubble sort, then there is insertion sort, then there is heap sort, quick sort, merge sort. There are multiple sorts. Okay, all of them take different time complexity based on different types of output. Okay, so what I mean here is, looking into the situation, whichever the environment the algorithm is going to run in, we have to find out that which algorithm will give us the best result. Okay, let me see if my audio is coming or not. Yeah, it's coming. Great. So we just have to check that in which environment will which algorithm perform the best. Okay, so according to that, multiple algorithms are given. So this is called design approach. First, you have to see the necessities, the requirements, or all the processes that this algorithm will come into use, and then see what are the possible input data sets. Okay, and with that data set, which is the best algorithm to apply for sorting. This is a basic example, and this is what is a design approach is. First, you have to look into the problem, see the data sets, and gradually proceed into selecting the algorithm. Okay, accordingly designing the algorithm. That is all what is design approach is. Then there is analysis. First, the very first example that I gave is time complexity. What is time complexity? The time taken by an algorithm to complete a particular task. Okay, here we are not talking about the input. The input is going to come later on. But yes, first we take the input from the user. Okay, it goes into the algorithm. Algorithm does something inside it, some functionality, and then it gives an output. Okay, so there can be multiple algorithms. We just have to check which algorithm has the lowest or the least time complexity. That is what is needed for better efficiency. Okay, now there is two types of analysis. First is exact analysis, and there is approximate analysis. Okay, now what is exact analysis? In this case, let's say this is my laptop. I have to analyze that a particular algorithm, let's say a insertion sort algorithm, how much time will it take? So not just the algorithm we have to look into, there are also physical aspects we have to keep an eye on, like my processor, my RAM, my bandwidth, different things, my cache memory, everything will be come into account, and then from those steps we'll dive into a result which will give us exact analysis. Okay, but there is a crux to it. There are different computers in this world. Every computer has a different processor, different RAM, different cache memory, everything, different operating system, even that is different. Okay, different materials with which these things are made. So temperature, physical quantities. Okay, these all are different. So there can be gazillions of permutations and combinations with which we can come out. Okay, so we can't just do exact analysis of every computer and see if the algorithm is working or not. So we just do a simple thing that is called approximate analysis. Okay, now what is approximate analysis? This is just a basic analysis of the algorithm just itself, ignoring the physical quantities or the physical aspects like RAM, processors, bandwidth, cache, temperature, everything. Okay, material, everything. These are just excluded. We just look into the algorithm and see how efficient it is. That is called approximate analysis. Coming into approximate analysis, there is one type. There are many types, in fact. One of them is asymptotic analysis. We'll dive into that later on. First of all, let's just continue with what is the algorithm. Okay, so we just now understood that an input is given to the algorithm solves the problem and then gives an output. Okay, one or more than one output is necessary, not just printing, at least the manipulation of the data. Okay, or some visible or what I'd say noticeable change has been done to the data or the program, whatsoever it is. Okay, that is what an algorithm. If your algorithm doesn't, let's say you have some approach, okay, that does not satisfy this condition that it takes an input, it may not take an input, but is doing no change to the our program or a data set whatsoever. Okay, so in that case, that won't be considered as an algorithm. Okay, that won't satisfy the needs of an algorithm or becoming an algorithm. So this is what it is. Now, there is also a thing ki bhai, algorithms take input, that we just understand. Okay, we just understood that algorithms take input, but a person is giving input as 10, 2, someone is giving 20, someone is giving 100, 200. Okay, but there comes a smart student and he gives input of 1 lakh. Okay, now the time taken to, let's say the algorithm is multiplying two numbers. Okay, let's say it's finding out n square. Okay, now the one person gives n square, n is equals to 2. Okay, in that case the output will be 4. That is easy for the computer to do. Within seconds it will do it. Okay, but when it comes to, let's say, 1 lakh, a person comes and he gives the input as 1 lakh. Now 1 lakh square is too much. Okay, so the computer in that case will be responding relatively slower. when compared to that 2 wala input. Okay, so that is why we have made a graph that as the input size increases, the time decreases. Now, this is a simple graph that's not exactly true in all the cases, but still you have to design an algorithm which has not a very steep graph but very flat graph. Like third one, let's say there are 3 algorithms. Okay, 1, 2 and 3. This is 1, this is 2 and this is 3. In this case, a person asks me which algorithm is the most efficient algorithm. So I'll say one second. If a person asks me which is the most efficient algorithm, let's say we give an input this size, this size, this size, this size. Okay, what is happening? The time for this graph is increasing exponentially. So this is a very bad algorithm when compared to these two. Then similarly, this algorithm is slightly better, but still not the best. But when we see this algorithm, the graph of this algorithm, what is happening? Even if the input is increasing, the time is not increasing as fast as the input, like the other two. Okay, so here which one is the most efficient algorithm? Third one is the most efficient algorithms. Okay, now it's not necessary that there will be a straight line. Okay, there can be a curved line or something like some different figure. Okay, many algorithms have different graphs. This is just an example that I've taken. Okay, now characteristics of algorithm. Now I know we have already discussed the characteristics of algorithm that the input should be 0 or greater than 0. Okay, that is written here. The input should be 0 or more than 0. The output should be 1 or more than 1. Not necessarily an output which is displayed on the console, but can be a data manipulation also. Some programmatical changes should be done in the code. Okay, that is what is the necessity or what is the meaning of output, not necessarily a console, cout or printf output. Okay, now the third point is definiteness or unambiguity. What does this mean? Unambiguity you must be familiar with back in object-oriented programming sessions, but let's just revise it. Okay, now let's say I tell the computer that add 6 or 7 to x. This is what I write. Okay, what I write? I say add 6 or 7 to x. Okay, now what will computer understand from this? Absolutely bullshit. Okay, what is this? 6 or 7? The computer doesn't understand your emotion. Okay, so 6 or 7 is unambiguous. Computer won't understand what is 6 or what is 7, or either which one of them to add to x. Okay, so this is what is called ambiguity. Okay, so we have to clear all the ambiguity from our algorithms. That is the basic thing we need as a characteristic in a program. That is the necessity. Also in algorithms we have written it as characteristic that it is unambiguous. It is definite. Every step is clear. Every step we can understand what is being done. Okay. Now similarly there is also a thing, finiteness, that there should be finite number of steps. There shouldn't be like 1 lakh line of code and a person isn't able to understand that what is happening. Okay, he'll be terrified. Okay, so this is not what an algorithm is. To make an algorithm efficient, there should be finiteness. Okay, there should be some certain number of steps. Okay, and also if not steps, let me tell you a very good situation. Like for example, there is a game of chess, So what does a computer do when it understands that if this particular move is going to win us the game? Okay, an algorithm could be devised that decides whether any given position in the game of chess is a winning position. Okay, now the algorithm works by examining all possible moves and counter moves that could be made from the starting position. Okay, the difficulty with this algorithm is that even using the most modern computers, it takes billions of years to take the decision. The perfect decision that they say is gonna take billions of years with a computer. Okay, so what I'm I'm saying is, this is infinite steps. Okay, it's gonna take infinite number of time. But in this case, there is finite step, and the program is gonna terminate in a finite time, in a particular efficient finite time. Okay, it's not gonna run infinitely. So this is what an algorithm needs, that it is finite, it has finiteness in it. Okay. Fifth, effectiveness. Every instruction is clear. Okay. Now also, I'm once again gonna read you something, that the possible output or the actual output might differ. That is not an effective algorithm. Every time with the same test cases, with pen or paper or with the computer, the output should be correct and same. That is what is needed in an algorithm. We can't just rely on the computer for the best output. It should match the real world. Let me tell you an example. Performing arithmetics on integers is an example of effective operation. Okay, but arithmetics with real numbers is not, since some values may be expressible only by infinitely long decimal expansions. Adding two such numbers would violate the effectiveness property. That is what I'm saying. Okay. Now, by the way, there is something called computational procedures. What is it? Algorithms that are definite and effective. They are definite and effective. Those are called computational procedures. Okay. This is what's written in this book of Alice Horowitz. Okay. Now moving forward. So, how many times is this first line gonna execute? Tell me that. Pause the video and just think, how many times will this first line, I'm not talking about the whole loop, I'm asking, this first line will execute. Pause the video and think. Okay. According to me, and I'll prove it to you, yes, this is gonna happen. According to me, it is n plus 1 times. You might ask, nahin, this is gonna execute n times since the condition is n. Let me tell you again. The statement which is inside this for loop is going to run n times. But this is going to run n plus 1 times. How? Because let's say became I became equal to n. Let's say n was 10, I became 10. This condition will satisfy, this will execute, this will become n. Okay. Next time again the loop will run, that becomes n plus 1. Then it will check the condition I is now greater than n, and hence the loop won't proceed further and terminate. Okay, this is going to happen. So what happened? This line will execute n plus 1 time, and this what's beneath the loop, that will execute n times only. Okay, so what's the time complexity here for this loop? The time complexity is, since it's gonna run n times, time complexity is going to be big O of n. Now, there is quite a possibility that some of you people won't be understanding this time complexity concept. So I'll make a separate video for that. Okay, a separate video for time complexity and space complexity. Don't worry about it. I'll be making this video. Just subscribe to the channel and you'll get it. Okay, so the time complexity here is big O of n. Is that clear? The time complexity is big O of n. Now in the same program, there is another loop. This is another loop. This first loop's time complexity is big O of n. This loop's time complexity is big O of n square, that we all know. Okay. Now how many times will this x plus is equals to y execute? Can anyone tell? If you're good at mathematics, this is just a cakewalk. Okay. It is gonna run n squared times. How many times? N squared times. Why? I am not going to tell that. That's mathematics. That's basic mathematics. If you don't know that, please write in the comment section. I'll give a link of some site for you to understand. Okay. Again, understand. DSA needs mathematics. This is not just programming. Basic mathematics is what's necessary. There is another thing. One more thing that I'll write. That is x plus equals to. Now, what's the time complexity of this whole program? The time complexity of this whole program can be written as follows. TC, that is time complexity of course. Then comes plus. We are adding the time complexities now. The person who is not understanding how is this added, please just relax. Look, watch the video till the end. I'm making another video of time complexity and space complexity, especially for you people. Okay, don't worry. Again, then there is n square, and which is for this particular loop. Okay, that's n square. Then comes constant time complexity. Okay, this is what the time complexity of this program is. Okay, which equates to what? Smart people will say n square. Okay, the time complexity for this program is n square. You might ask why. Now O of 1 is a constant time complexity, we can ignore that. O of n when compared to O of n square, basically n is obviously very low than n square. Okay, that is the possible, that is the approximate thing that we do. Okay, what did I say at the very first place? That we are doing approximate analysis. So this is approximate analysis, O of n plus O of n square. So n can be neglected, so we are writing O of n square. Okay, so this is the largest value. You know what I think? For now, I should end the video here. Okay, I'll make another video for asymptotic notation, since this video is already getting so long, and that is not good for my views. Okay, for my growth of my channel. So it's better to make another video. And many people have requested me to make short videos, since it's my habit to make videos stretching to 2 hours, 3 hours. Even I've made a video of object-oriented programming for 8 hours. So that is what I do. That is my, my thing. So yeah, since many people have requested that I should make videos not longer than 20 minutes. So this is all about it. This was the first class of DAA. I'll be proceeding further sessions in the upcoming classes. Upcoming videos, sorry. Upcoming videos. And see you. Bye-bye.